Okay, homework 10 is due tonight. Here's my public service announcement of the week. It's almost registration time. So if you have not yet met your mentor, you have to do that before you can register. So make your mentoring appointment and meet your mentor so that you can register.
You're not going to teach Calc 2, are you? Next semester?
I don't have a Calc 2 section next semester. No.
And
I apologize. I have a discrete math section.
What's the process to get like a specific class? They like apply for it? I mean, like,
Oh, to be able to teach a
Yeah.
class? It's like a little bit request, a little bit like mostly request. A little bit, there's like some, hierarchies that happen, but yeah. I don't often request Calc 2.
Who's the best Calc 2 teacher?
I don't know. Who's teaching it?
I don't know.
Let's see. I'm sure you'll find someone great. I don't know who's teaching it, but I'm sure you'll find someone great. There's only 4 teachers. Yeah, because there's not very many sections of that, right?
3 of them have elbow reading.
3 of them do? Well, pick the other one.
last one, like synchronous online.
Oh,
Which one doesn't have word wording?
that's the one that's synchronous online, they said. Sometimes ratings are, we're gonna do 2 examples of acceleration, velocity, and position. So tell me, how are acceleration, velocity, and position related to one another?
Velocity is the derivative of position.
Velocity is the derivative and acceleration
Is the derivative of the derivative.
is the derivative of the derivative. Great, so velocity is the first derivative and acceleration is the second derivative. So if I have position, velocity is the first derivative and acceleration is the second derivative. So if I know something about acceleration and I want to get back up to velocity or position, how do I undo a derivative? The antiderivative. So really, these questions are just exactly what we did on Wednesday, where I have the velocity, I have the acceleration, I want to get to the position. So I have the second derivative. I'm going to go backwards using the antiderivative. And at each step, I'm going to find that constant C. Okay, so that's what I'm going to do. This one says a particle moves along the y-axis with an acceleration of 2. Acceleration is 2, where t is time in seconds. The particle's velocity at time 2 is 5, and the particle's position at time 2 is 10. What is the position at time 6? So I need an equation for position so that I can plug in 6, okay? I know an equation for acceleration. I know the position and the velocity at time 2, and I need an equation for position. So how do I get from acceleration back to position?
So 2x.
Yeah, okay, so let's do velocity is going to be the antiderivative of acceleration, or the antiderivative of 2. Okay, what's the antiderivative of 2? 2x. Did we have an x? T, okay, yeah, let's use 2t plus c, right? I get that whole family of antiderivatives. I'm going to find out what that c is. What am I going to use to find out what that c is? Yeah, the velocity at time 2 is 5. So when I plug 2 in for t, it should spit out 5. So 5 is 2 times 2 plus c, tells me that c is 1. Okay, so velocity is 2t plus 1. All right, if I have position, if I have velocity and I want to get to position, what do? Take the antiderivative, yeah. Okay, antiderivative of 2t is t squared. Antiderivative of 1
Plus t.
t plus c, another c, yeah. I'm going to find this c by knowing that the position at time 2 is 10. So when I plug 2 in for t, it should spit out 10. So 4 and 2 is 6.
S of T.
That says S of T. That's how we usually write position with S of T. I don't know why. Like, I know why we use M for slope, but I don't know why we use S for position. You think I would, because I have a physics degree. Oh. It's too long. I do. I got a double major in college. Okay, but I'm not done yet, right? I gotta plug in 6 for T into where? Into the position function, right? So let's write down the position function. The position function is T squared plus T plus 4. The question said, what's the position at time 6? So I'm gonna plug in 6 for T. 6 squared plus 6 plus 4. 46. Can I give it some units? Let's check. Centimeters. Yep. 46 centimeters.
So starting from,
Acceleration, which is the second derivative. Yeah. And we did.
so we can always start like that if because the acceleration is 2, we just put 2t.
Yeah. I mean, if the acceleration is something else, we'll have to put something else, right? Yeah.
So if it was a like a function, then
We would have to integrate it just like we do all the other functions. Yep, absolutely. Oh, it told me up here, at time 2, the position was 10 centimeters. So we just said, and it has the velocity as centimeters per second, right? So. Good. Okay. Okay. A coin is dropped from an 850-foot building. What does that tell you about your position or velocity or acceleration? Your position at time 0, right? If you're dropping it from an 850-foot building, then your position at time 0 is going to be 850 feet. So this tells me that S of 0 is 850. The velocity of the coin is negative 16t. Find both the position and acceleration functions.
well, won't the acceleration be negative 600?
Yeah, okay, so let's go back to that thing we wrote at the top, right? Position, velocity, acceleration. If we go this way down, we take derivatives. If we go this way up, we take antiderivatives. Okay, so I know that the velocity is negative 16t. If I want to go down to the acceleration, what do? Take the derivative, yeah? So derivative of negative 16t is negative 16. If I want to go up to position, what do? Antiderivative. Oh, I can't write this. Antiderivative. Okay, great. So S of t is the antiderivative of velocity, which is the antiderivative of negative 16t.
Find the position function and the acceleration function.
That's what it said. Yep, find the position and the acceleration. Okay, so to integrate negative 16t, I add 1 to the power.
So negative 8t squared.
Yeah, negative 16t squared over 2 plus c. So S of t is negative 8t squared plus c. Remember we said that at the beginning, when I very first drop the coin, my position is 850. So when I plug 0 in for t, oh my gosh, my position should be 850. So that's gonna help me find my constant there. 850 is -8 times 0 squared plus c. So c is 850. So my position function is gonna be -8t squared plus 850. Okay, I am ready for homework questions. 12. 16. 9. 22. 9, 12, 16, 22. 9, 12, 16, 22, 23. You good? Yeah. Okay. 9, 12. My mouse is like not behaving today. Thirteen. Sixteen. 22. Did someone say 23?
Yeah.
Yeah, okay. Okay, here we go. 9. 9 says evaluate the integral. Oh man, we don't know anything that has like quotients in it, right? So what should we do to this integral so that we can evaluate it? Yeah, bring it to the top. Let's simplify, right? Whenever there's just one thing in the denominator, you can break it into 2 pieces. So this guy can be written as 2x to the 4th over x to the 4th minus 2.5 over x to the 4th. So in the first term, the x to the 4th just cancel. And in the second term, it's 2.5 x to the -4. And then what?
Oh, just fine.
Then you just find the integral, right? So integral of 2 is 2x minus 2.5 x to the, add 1 to the power, -3, divided by -3, plus c. Okay, check. That one was easy.
Could you just bring it, like, could you solve it with 2x to the 4th minus 2.5 x to the -4?
You have to distribute first. Yeah, because we don't know a product rule or a quotient rule. So it can only look like add, or add and subtract.
Oh, I do that. Like, I wrote like that.
Yeah, I did the same thing.
It said
I
no.
wanted to put the x at the bottom, so it'd be like 3x to the negative 3x to the 3.
No. Maybe you weren't putting the negative in the bottom. Maybe you were missing that -3. Usually if you type it in correctly, it should take it no matter what, because it's like an engine behind there, like checking that they're mathematically the same. Just be careful because this is -2.5 and -3, so this will make positive. You could bring this down and make it in the bottom instead. There is one that's not working. Well, only in some iterations. I sent a ticket in, but we'll see. Okay, I will do one of these. They're both very similar, so we can pick which one. Does anyone care whether it's A or B? This is number 12. Does anyone care whether it's A or B? No. So the only difference is that they change the constants, right? But it should work out exactly the same way. So I have the third derivative, and I want to get back to the original function. If I have the third derivative and I want to get back up to the original function, how am I going to do it? Take the antiderivative 3 times. Every time I take the antiderivative, I'm going to find my constant. Yeah, so every time I take the antiderivative, I'm going to find my constant. So my function, the second derivative, is going to be the antiderivative of this thing. Oh, it might be hard because there's that in there, right? Is it on your sheet? I think it's on that sheet on the very last page of Monday's notes. Check the sheet on the very last page of Monday's notes. Remember, we did an example where we had e to the a times x. Is it on there? It's kind of like, it's like, yeah, we're gonna practice this more next week, but they have them, I think, on their sheets. So like e to the ax is 1 over a, e to the ax.
Yeah, that one is.
Sine of ax is -1 over a, cosine ax, and cosine is 1 over a sine. Whoops. Yeah.
Would it be true, like, say that if you had to use the chain rule? to
No.
get the derivative, no?
No,
Just
so
that
it's only true because it's just a constant times x in that. Yeah. It would not be true if there was like an x squared in there or something. Yeah, that's what we're gonna practice next week. What do we do if there's like an x squared in there or something like that? Yeah, does that make it easier now or should I keep going?
I mean, mine, it's like, I think I'm getting confused with the negatives and everything.
Okay, so let's do it.
Like the
Okay.
antiderivative.
Oh, gosh. The antiderivative of cosine is sine. Because it's -3 inside there, I gotta put this -3 in the bottom. So I'm gonna do a little bit of simplifying. F double prime of x, -27 divided by -3 is +9. Sine -3x plus c. I'm gonna do the second part because I can see it. So I'm gonna use this information to solve for c, okay? It says when I plug in 0 for x, it spits out a -1. So when I plug in 0 for x, it spits out -1. So -1 is 9 sine -3x. No, -3 times 0, plugging in 0 for x. Plus c. Sine of 0 is 0. So that tells me c is -1. F double prime of x is 9 sine -3x minus 1. Ooh, if you didn't get vaccinated yet, or you're eligible for a booster, Gwinnett County is doing Vaccines Are Not Scary today and tomorrow at the Sears Gwinnett Place Mall there, and you can get a $100 Visa gift card. I know. You can make all kinds of money if you're willing to get like vaccines over and over again.
What is the interval of cosine of 3x in this case?
The integral of cosine 3x is sine 3x divided by 3. So just divide by that constant inside it.
Okay.
If you had like -a cosine -x, would that cancel out negatives or no?
No.
No. Okay.
Wait, let me see. Cosine
So you
is
have
an
like,
even function.
it's like line that I'm getting confused on is like,
Because you're getting too many negatives there.
yeah, it's like I'm getting confused with the negatives.
Yeah, we're gonna have another negative come out here, so let's keep going. Okay, if we get back to the first derivative, I have to do the antiderivative of this guy. Okay, so I have 9. Antiderivative of sine is negative cosine over -3 minus antiderivative of 1 x, yep, plus c. Okay, and look, these negatives cancel again, yeah? So the negatives only cancel when they're both outside the sines or cosines.
Okay.
You can't get rid of them inside. Okay, so f double prime, 9/3 is 3 cosine -3x minus x plus c. Okay, let's go find our coefficient, our constant there. We're looking in the first derivative. This one. F prime of 0 is -1. So the first derivative, when I plug 0 in, it spits out -1. Might need more space.
You wrote double prime by accident.
-1 is 3 cosine -3 times 0 minus 0 plus c. Okay, cosine of 0 is 1. 3 times 1 is 3. I got to move it to the other side. -3. So -1 and -3 makes -4. -4. Let me put a page in here. Oh, dear Lord. Okay, so f prime is 3 cosine -3x minus x minus 4. Okay, I have one more time. F of x is the antiderivative of this guy. Okay, so 3, antiderivative of cosine, sine. Put a -3 in the bottom because it's -3 inside there. Okay. Antiderivative of x. Yeah, x squared over 2. Antiderivative of 4, 4x plus c. Okay, I have one more c to find. Need another color. I don't know. What have I used already? Purple? I might have used purple. This is the regular function. So I'm going to scroll up and find c from the regular function right here. F of 0 is -9. F of 0 is -9. So when I plug 0 in for x, it should spit out, was it 9 or -9? -9. Okay, 3 over -3 makes -1. So negative sine -3x minus 1/2 x squared minus 4x plus c. -9 is negative sine -3 times 0 minus 1/2 times 0 squared minus 4 times 0 plus c. Sine of 0, 0, 0, 0. C equals -9. Okay, so I got negative sine of -3x minus 1/2 x squared minus 4x minus 9. That was a lot of work. Twice. Okay, let's see what's next. Find the antiderivative. Oh, this is that same rule, right? There's that number in there. We should have done, I'll have to add an example like this to the notes. It's that same rule in there. Okay, so I have to take the antiderivative. Okay, add 1 to the power, 7, divide by the new power, minus antiderivative of sine, negative cosine 5x, because it's not just an x in there, I gotta put that 5 in the bottom, plus c. Okay, I'm gonna do a little bit of simplifying and then I'm gonna solve for c. So I have 6.5 x to the 7th over 7 plus, because I have minus minus, so plus 2.5 over 5 is 1/2 cosine 5x plus c. I'm gonna use this, f of 0 is 6, to find c. Six equals 6.5 times 0 to the 7th over 7 plus 1/2 cosine 5 times 0 plus c. This guy's 0. Cosine 0 is 1 times 1/2. So I have to do 6 minus 1/2. 6 minus 1/2, 5.5. Go for it. Okay, so f of x is 6.5 x to the 7th over 7th plus 1/2 cosine 5x plus 5.5.
Scroll up a little bit.
Yep. I can try.
So in like the second step there,
Yep.
why do you have it kind of like written as 2.5 in parentheses negative cosine?
Because I didn't want it to be, I wanted it to be multiplied and not subtracted. Yeah. And if I don't put those parentheses, then it's gonna look like I have 2.5 as one term minus the cosine 5x over 5 as the second. Because I want to make sure that these two negatives get multiplied together to make it possible.
Oh, okay. That makes sense.
I never know whether I'm going too fast or too slow. So consider the function f of x equals 2 over x cubed minus 4 over x to the 7th. Okay, how are we going to do this one? Bring it to the top. 2x to the negative 3 minus 4x to the negative 7th. Okay, this one, look, in the end, they want me to find what f of 2 is, yeah? So tell me what I'm going to do to get to f of 2.
The antiderivative
Find the
of
antiderivative.
2, 3x's.
Not yet. I have to do something in between those two steps. What do I have to do in between those two steps?
Figure out what c is.
Find out what c is, right? So I'm going to take the antiderivative. I'm going to use this information that f of 1 equals 0 to find out what c is. And then I'm going to plug 2 in for x, and that's going to be my answer. So in the end, I'm going to get a number as my answer. I'm going to take the antiderivative. I'm going to use f of 1 equals 0 to find out what c is. And I'm going to plug in 2. Do it all? I don't know who asked this one. Do it. Yeah, sure. Equals. I can do it. I have faith. We'll cheer each other on. You could do it too. Okay, add 1 to the power. Negative 3 plus 1 makes negative 2. Divide by the new power. Minus. Add 1 to the power. Negative 7 plus 1 makes negative 6. Divide by negative 6 plus c. Before I plug in, I'm going to do a little bit of simplifying. Two divided by negative 2 is negative 1. And I'm going to put this guy back in the denominator, because if I'm going to plug in numbers, my life's easier if they're in the denominator than if I have to raise them to a negative power. But if you're using your calculator, it doesn't care, right? So you can leave it however you want. But if I'm using my head, it's easier. Okay, negative negative makes plus 4 over 6x to the 6th. I could have simplified that more, but we're fine. Okay, my information told me that f of 1 is 0. So when I plug 1 into this guy for x, it should spit out 0. So when I plug 1 in for x, it should spit out 0. Okay. C equals, so I have 0 plus 1 makes 1 minus 4/6 makes 2/6, 1/3. I think I get 1/3. Someone should check that. Okay, so that makes f of x -1/x² plus 4/6x to the 6th plus 1/3. Remember, it wanted me to find f of 2. So I'm going to plug 2 in for x. -1/2² plus 4/6 times 2 to the 6th plus 1/3. I don't know which one this is. 13? Is that what you said, Braxton? 16? Yeah, 16.
You're doing 22, right?
I think it's on the list. It's what you're waiting for. I'm not gonna put that in my calculator though. I could try, but your calculator is better than mine. Mine's old. It's like over the hill. Okay, 22. Let S of t denote the position of a particle at time t. Oh, good. We know lots of things about S of t. S of t, B of t, A of t. When I go this way, I take derivatives. When I go this way, I take antiderivatives. The particle is moving to according to the data. A of t is 10 plus 3t minus 3t squared. S of 0 is 9 and S of 2 is -4. What are those two things at the end going to help me find? My plus c's, right? Those two things at the end are going to help me find my plus c's. I started with acceleration. I want to get to position. How do I go from acceleration up to position? Take the antiderivative. How many times? Twice. I'm down here at acceleration. I've got to get up here to position. I'm going to take the antiderivative twice. Every time I take the antiderivative, I put in a c, right? In the previous examples that we did, we knew something about velocity. We knew something about position. We could find the c at every term. In this example, we only know stuff about position. So we're not going to be able to find the c's until we get all the way back to position. So when I say plus c, I'm going to have to use two different letters. I'm going to do the first one like plus c and the second one plus d or something, okay? So that I can keep them separate. Okay, velocity is going to be the antiderivative of this guy. So velocity, antiderivative of 10 is 10t plus 3t squared over 2 minus 3t cubed over 3 plus c. I'm going to simplify a little bit. You don't have to, but I'm going to, because this 3/3 is going to cancel, right? And that will make my life easier for the next antiderivative. 10t plus 3t squared over 2 minus t cubed plus c. Okay, position is going to be the antiderivative of this guy. What do you get when you take the antiderivative of a constant? What do you get when you take the antiderivative of a constant?
Constant t.
Yeah, like when you took the antiderivative of 10 here, you said, oh, that's 10t. Yeah, this is just some number. We don't know what number it is yet, but it's a number. So when I take its antiderivative, I'm going to get that number, c, times the variable t. Okay, well, antiderivative of 10t is 10t squared over 2. Antiderivative of 3t squared over 2 is 3t cubed over 2 times 3. Antiderivative of t cubed is t to the 4th over 4. What did we say is the antiderivative of a constant? A constant times t plus, yeah, let's use something else to distinguish it from this constant, right? So this is still a constant, but if I call it c, then I'm going to get confused, right? So I call the first one c, the second one d. You can call them c1 and c2 if you want to, right? Okay, let's simplify a little bit. Position is 5t squared plus 1/2 t cubed minus 1/4 t to the fourth plus ct plus d. Okay, mine said that s of 0 is 9 and s of 2 is -4. That's what mine said. That's what it says at the top, okay? So what am I going to do with this s of 0 and s of 2?
Plug in S0, figure out C. figure it out.
Yeah, I think that's the best plan. If you use the one with 0 in it first, then this is going to be 0. This is going to be 0. This is going to be 0. This is going to be 0, and you're going to be able to find D. Yeah, and then once you know D, you can use the other one. You'll plug in 2 for all the T's. You'll know what number this D is, and you'll just be able to find C. Okay. So I'm going to start with the one with 0. 9 is 5 times 0 squared, 1/2 times 0 cubed, 1/4 times 0 to the fourth, C times 0 plus D. So D is 9. Yeah. So now S of t looks like 5t squared plus 1/2 t cubed minus 1/4 t to the fourth plus c times t plus 9. Then are you going to use that guy? -4 is 5 times 2 squared, 1/2 times 2 cubed, 1/4 times 2 to the fourth, c times 2 plus 9. Okay, this one you have to use your old calculator. -4 is, okay, 5 times 4 is 20. Plus 4 is 24. Minus 4 is 20. Plus 9 is 29. Plus 2c. Uh-oh. I did it bad. 20 plus 4 minus 4. Oh, no, I did it okay. -33 is 2c. C is -33 over 2. So S of t is 5t squared, 1/2 t cubed, 1/4 t to the fourth, minus 33 over 2t plus 9. I think if you do 5 times 2 squared plus 1/2 times 2 cubed minus 1/4 times 2 to the fourth plus 9, you get 29. You can't put the 2 in there, right? Because it's attached to the C, and so it's not like terms. You have the number, the terms without the C, the terms with the C. So then I subtracted 29, divided by 2, got my C.
Is it -33 over 2?
33. Yeah, because -4 minus 29, I think makes -33. Okay. 23. I don't think we
It
need.
was actually 22 that I was having an issue with.
Great. I think 23 is like the other ones we've done, right? I can do it. I'm happy to do it if you want me to do it, because I don't want me to keep going. It gives you the acceleration. It wants you to find the position. How do you get from acceleration to position? Antiderivative twice, yeah? The first time you take the antiderivative, you're going to use your velocity to find your plus c. The second time you take the antiderivative, you're going to use your position to find your plus c. Be careful here because there's cosines and sines, and those negatives and positives trick you. Other Edfinity questions? 19. So I would do 19 by rewriting it as 7x to the -2 minus 10x to the -6. And then you'll use that at the end? Yeah. It's not taking it. I'll come help you. Yeah, I'll come help you. All right, have a great weekend.